going to go over problem solving lab 1 and just some similar like good answers and kind of what people do. So if we look at this again, problem solving. If you're stuck, try an easier problem, right? So be like, okay, well, if there's one person, obviously there's no clinks because who would you clink with? But if you have two people, what you have to realize is that they're only going to be one clink. So you might have double counted because if I meet you, I might go cheers and you go cheers to me. We don't later at the party go, hey, cheers again, right? We've already clinked glasses. So when you have two people, there's only going to be one clink. All right, and if you have three people, and I'm just going to draw a little thing. All right, so this person would, if I have three people, this person would be one clink, two clinks, and then these guys have to do it. So that's three, because the first, you don't clink with yourself, so you clink with two people, and then there's one other person, which leads us to three. And again, I'm purposely not using equal signs. Arrows are a good way to show your thinking so that you have something mathematically correct. So 2 plus 1 does equal 3, but sometimes kids, as we get doing math, arrows show thinking. So 3. So what if I have 4 people? Okay, so here's my 4 people. So say this is me. I would clink, and I'm going to switch to pen because that's not staying up very well. So I would clink with these 3 people. Okay, so I would clink with 3 people. Right, and then I'm done, right? I've already clinked glasses with A, B, and C, so I'm done. And then this person, if I move on to them, they have to clink glasses with 2 people. They've already clinked with me, so they're not going to do me. And then the last person has 1 person they would click with, which looks like 6, okay? So with 5, I'm thinking it's going to be 4, then 3, then 2, then 1 based on my pattern. So that's 7, 8, 9, 10. And so, again, starting with an easier problem is a great idea. Drawing a picture is a great idea. Anything you can do to kind of see what's going on. So like with 2 people, I just kind of drew the line between them. With 3 people, I drew kind of 3 circles and did a triangle, like one person clinking with the other person clinking with another, and then the 2 that hadn't clinked. 4 people, I drew 4 dots, kind of in a square formation, like on a dice. And so the first person, I drew lines to all 3. The second person, I drew lines to the other 2. And then I connected the last 2 parts. So it kind of ended up looking like a square with an X in the middle. And then with 5, I didn't draw a picture because I know that the first person's going to clink 4, then 3, then 2, then 1, and 10. So it looks like if I have 20 people, that I'm only going to have 19 clinks because I'm not going to clink with myself. So it looks like it's going to be 19, 18, 17, 16, 15, 14, oh my, what did hopefully I'm not missing. You guys can yell at me if I do later, tell me I made a mistake. But I'm gonna go all the way down, 6 plus 5 plus 4 plus 3 plus 2 plus 1. So I did 19 plus 18 plus 17 plus 16 plus 15 plus 14, all the way down to 5, 4, 3, 2, and 1. And we're just adding these all up. Now again, you can just add these all up. You could look for 20s though. So if you look, like 1 and 19 make a 20, 2 and 18 make another 20, 3 and 17 makes another 20, 4 and 16 makes a 25, and 15 makes a 26, and 14 makes a 20, 7 and 13, 8 and 12, 9 and 11. And then in the middle, I have this 10, okay? So I have a bunch of 20s, and then, you know, I could count the end. So let's see, how many did I have? I had, what? 1, 2, 3, 4, 5, 6, 7, 8, 9 sets of 20, and then what, the 10 in the middle maybe? So maybe 10 sets, is that what I said? 1, 2, 3, 4, 5, 6, 7, 8, no, 9 sets. 9 sets of 20 when I kind of paired them up, so that's what, 180, and then the 10 in the middle. So that kind of looks like the answer might be 190 clinks. Another way to do this when you add it up so you don't get that weird 10 in the middle, and I'm just going to jump to some paper, is you could do 19 plus 18 plus 17 plus 16 dot, 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 and then do your 4 plus 3 plus 2 plus 1. And since you have an odd number, that's why you had that 10 in the middle. So I'm just going to leave the 19 off, and I'm going to add the others up using the same method. Except 18 and 1 makes 19 this time. 17 and 2 makes 19. 16 and, 3 makes 19, 15 and 4 makes 19. So I'm going to get a bunch of sets of 19. And since I have 18 things that I'm pairing up, I know I'm only going to have 9 pairs. Because if you have 18 things and you're pairing them up, you're only going to have 9. And so then, but notice, look what else you have. You have this other extra 19. So I have this extra 19 that I started with. So I really don't have 9 19s. I actually really have 10 19s, which is 190. Okay. Now, sometimes students get an answer of 380. So they might remember some math from way back when. They're like, well, I took 20 times 19 and I got 380, and they're like, well, I did it wrong. And this is why I wish we could have talked about this today in class, is because I love these favorite wrong answers. This is actually one of my favorite wrong answers, because if you look, this person has a lot going on. Okay, they didn't get the right answer, but they're close. Okay, you have 20 people and they all clink 19 times. Okay, but why is that the problem? What's wrong with that? So I have 20 people clicking 19 times. Well, the problem is you're counting person A clinking glasses with B, and I'm just drawing a capital A with a B with an arrow in between them. But you're also counting B clinking glasses with A, and again, I'm just drawing a B with an A with a clink in between them. So you're double counting. You're counting A with B as one clink, and then B with A as another clink, and the reality is they would only clink once. So how can we fix this answer? This is a great start, right? And so, everyone okay, if I divide that by 2, now suddenly I get the right answer, because this person, the only error they made is they double counted. They counted AB as the same as BA. And so if we divide by 2, we fix that error and we get the right answer, okay? So lots of strategies there. Those are the main ones. Again, sometimes people, double count and so forth. All right, I want to look at number 2. John grabs 8 cookies, all right? His mom took some away, and now he only has 2 cookies. How many did his mom take away? And I'm going to I have some circular tiles here that are pretty common. Kind of teachers have beads again a lot, or, like little teddy bears or little plastic tools that they use called manipulatives in class. And so this might seem easy to you, but I want to just talk about, for especially those of you that are doing early childhood, what this entails. It says John grabbed 8 cookies. So the first thing that little kid is going to have to do is grab the manipulatives. And if you want to practice this, you could get like pennies at home and count 8. So 1, 2, 3, 4, 5, 6, 7, 8. And not all preschoolers or kindergartners can count to 8. Then his mom took some away. All right. So they don't know to subtract. They're going to take one of these little tiles away, and they're going to count again. So they're going to go 1, 2, 3, 4, 5, 6, 7. And they're going to touch the tiles as they count. And they're going to get 7. And then they're going to have to read again. Oh, he only has 2. That did not work. So then they're going to take the manipulatives and they're going to take another one away. And then they're going to touch and count. So touch 1, touch 2, touch 3, touch 4, touch 5, touch 6. They're going to be like, oh, I still don't get 2. So they're going to take another one away and count. Another one away and count. Another one away and count. And another one away and count. Finally, they're going to have 2 cookies left, and they're going to be like 1, 2, and they're going to touch and count, and they're going to be like, oh, good, I got it right. But now they have to realize that the answer is the other pile. It's the 6 little manipulatives that they have slowly pulled apart. So then they have to go over to that pile and go 1, 2, 3, 4, 5, 6 to get the correct answer. So in number 2, you might think, oh, that's, why did Julie even put that on here? That's not problem solving. This is problem solving to a preschool or kindergarten, all right? So again, they might have 8 cookies, and I'm just going to draw 8 circles, and they're going to just keep taking them away, taking them away, taking them away, taking them away, and I'm just going to put the circles in another pile, so they're going to keep taking away, taking away. So they're going to end up moving 6 circles to the other side until they can count 1, 2 circles. Then they're going to go to the ones they took away and count those and get 1, 2, 3, 4, 5, 6. And again, some of you just might have done 8 minus 2 equals 6. But as we work on early childhood math, you're going to realize that is problem solving for a little one. All right, let's look at the next one here. On this one, and where's my, there it is, my timeline. This one, a lot of times when I was looking at work, a lot of people draw a timeline from A to B, A to D, and they put B in there and C in there. Now, guess and test is a great strategy. So if you're stuck, just put like 100 miles, 100 miles, 100 miles and see if that works. I did look at some work, and some people take 390 and they divide it by, oopsie, if I can write 390, and they divide it by 3, and they just go ahead and put it in between the things. So they have a number line, and they start with A, ends with D, and they put 2 hash marks in the middle, the first one B, and then C. So it goes A, B, C, D on the number line. And so what they do is they take 390 divided by 3, just because it's kind of like an average. They're like, well, I'm just going to average it out. So they put 130, 130, and 130 for the 3 segments A to B, B to C, and C to D. They label them all 130, 130, 130. But then they're like, well, that can't be right. So guess and testing doesn't mean you just do random stuff. You can use an educated guess, but they know this isn't right. So it says driving from A to D, pass through town B, then through town C. From A to B is 10 miles further than from B to C. So they're like, oh, that needs to be 10 further. So maybe I should make, I don't know, maybe BC needs to be 120, okay? Or maybe they make this 140. You know, you don't quite know what to do. So they're like, okay, I'm going to make B to C 120 so that A to B is 10 further. All right, let's read it. Driving from A to D, pass through town B, then through town C. From A to B is 10 further than B to C. So right now, that's true. I have B to C as 120, A to B 130. But then it says from B to C is 10 further from C to D. So now it's like, oh, that one has to be 10 further. So I could make this one, I could go down, let's see, this would have to go down to 110 if that's the case. So C to D is 110, 10 further is 120 between B and C, and AB is 130. But then if you add it up, you lose that whole 390 thing. So then you're like, okay, well, maybe I should just increase them all by 10. So if this guy's 120, this guy's 130, this guy's 140. And so if I add those up, do those add up to 390? And that's actually looking pretty good. Okay, and then it says if A to B is 390, how many miles from A to B? So it looks like A to B is going to have to be 140 miles. Now, the other thing is some people do algebra on that. So again, you're still going to draw probably a number line and start at A and then do 2 hash marks in the middle, call them B and C, and then a final hash mark D. Now let's do some algebra. The last thing we talk about is C to D, so let's call that X. That's our variable. We don't know how long it is. We know B to C is X plus 10, so I saw some people doing algebra. And 10 more is X plus 20, because if you add 10 to the 10, you get 20. And then you know all of those add up to, what, 390. So you have X, X, and X, so you have 3X plus 20 and 10 make 30 equals 390. Subtract the 30. So you get 3X equals what, 360? Divide by 3, X is 120. Now, 120 is the distance between C and D, so you sub it back in, that's 120. Sub it into B to C, 120 plus 10 is 130. And A to B, you would add 20 to that, which is 140. So you could do algebra to get that. You could do guess and test. I have some students that just guess 100, 100, 100, and then they adjust up until it equals 390. Lots of methods that you can do on that one. All right, let's look at 4. All right, so on 4, when I look at student work, a lot of times what students want to try is they'll do 5, 4, 3 times, oh, sorry, helps if you read, use 6 and then 5 and then 4 together. So if you have 6, 5, 4 to go big to biggest number you could possibly make, and then they do the other leftover digits as 3, 2, 1. So again, digits are like, this is a 3-digit number and a 3-digit number, and I have 2 of them. That's what the direction says. All right, so you have 2 3-digit numbers. And sometimes students, when they get in class and they work in groups, they're like, oh, I totally misunderstood what that was saying. And then the word product means to multiply. So there is some vocab on this one. And I did say you can use a calculator. So if you take 654 times, what is that, 321, you get 209,934. And you might be like, oh, I found the biggest number. But when you think about place value, you're like, oh, maybe I should do 6, then a 5, and then maybe put the 4 back with the 6 and the 3 with the 5, and put the 2 back with the 4 and a 1 back with the 5. All right, and you might try that and see what you get. And then you might be like, ooh, maybe I'm not quite doing that right. All right, the next video will keep and pick up there.